Hello and welcome. Today we're going to be working on a JavaScript problem. We're going to be utilizing Code Wars today. And the problem that we're going to be working on in particular is very common. It's relatively basic, but we're not going to so much focus on the algorithm or the logic of the problem. What I really want to focus on today is much more our problem-solving framework. So that's something that we've discussed before, and it's that idea of having these rules or this set of instructions that we can utilize to help us to solve these types of problems. And there's one part of that problem-solving framework that I find that beginner students really seem to unintentionally omit or tend to gloss over. So I really want to focus very much on that one part, which is kind of the middle part of this framework. So if you remember, as we walk through this idea, these rules, this solving framework, the first step is to read and understand the instructions. The second is to define our inputs and outputs. The third, which is that middle one that I've talked about, is where we really formulate our algorithm. We kind of develop our plan, how we're going to go about solving this. Then we write our pseudocode. That's number four. And then we write our code. So quite often when you'll see similar types of frameworks described, in many places online, you'll go from the instructions and the inputs and outputs and then go straight to pseudocode quite often. And that's because for a lot of more experienced programmers or folks who have been doing this for a while, the process of writing your pseudocode and formulating your algorithm can often go hand in hand. So folks can kind of do them simultaneously. However, what I found is that for beginning students, it's more difficult to do that. Oftentimes I'll see students who will write pseudocode that's too close to the actual code. It's too close to being syntax. And you're kind of looking at things more from the perspective of the programming language and not from the perspective of just figuring out what is it I just need to do here? What is my plan? And that plan, that algorithm really should be language agnostic. It should have nothing to do with programming at that point. So that's why I really like to isolate that part of the process. To really focus in on that. And once you get really good at it, then that can become more a part of your pseudocode writing process. But for right now, we're going to kind of pull that part out. We're going to make it its own step. So let's go ahead and take a look at this problem. The parts of it that I'm not focusing on, we'll go through a little bit more quickly. So first is to read and understand the instructions. So it says, if we list all the natural numbers below 10, that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. So this is giving us some context just about what this problem is going to be about. And then it says, finish the solution so that it returns the sum of all the multiples of 3 or 5 below the number passed in. So I can say, okay, so it talked about this idea of I want multiples of 3 or 5, all the ones that are below a number. So we have the example of 10 here. However, in our function that we need to write, this number 10 is going to be substituted with some unknown number. We can think of that number as like the ceiling or like a maximum number. Something I'll point out here briefly is this is a good example of really understanding instructions, being sure you are crystal clear on exactly what it's talking about and what's being asked of you. So for example, it says, if we list all the natural numbers, I might want to stop there and remind myself, natural numbers, what are those again? Like, do I need to just refresh myself and make sure? I think I know what that is, but let me be sure. Let me do a quick internet search and see, am I correct in what I'm thinking about what natural numbers are? Or even here, multiples of 3 or 5. When the person who wrote this, when they say multiples of, are they thinking about it the same way that I'm thinking about it? Or should I clarify that? So this is just a good example where it might be obvious, but don't always assume that it is. It might not be. Don't be afraid to take a moment and do a quick search and look these things up and make sure that you're crystal clear on exactly what's being described and what's being asked of you. There's a couple more pieces of information here. So additionally, if the number is negative, return 0. So that would be an edge case for us. They're saying if that passed in number is negative, just automatically make it 0, automatically return 0. And then note, if the number is a multiple of both 3 and 5, only count it once. So they're giving us it's like a constraint there, essentially. If it's a multiple of both things, you only need to count it one time. All right, so those are my instructions. What are my inputs and outputs? Well, I know that my input is a number. I can look at my my function definition here and see that I'm getting in number. The name of it is actually number. That's nice and clear. I appreciate that. It's telling me that I'm going to be given a number. There's a number passed in. And then for my return or for my output, it says here it returns the sum. So again, I can assume here quite safely, what I need to do is return another number, right? So if I want to think of these as integers, that's fine. But you want to be clear about knowing what exactly am I being given and what the data type is. What do I need to give back and what the data type is? And just being very clear about, are we talking about numbers? Are they integers? Are we talking about strings or Booleans or data structures, like arrays or objects, etc. So you want to make sure that, again, you're crystal clear about that, inputs and outputs. Okay, now, before we get to our pseudocode, the next part that I was describing is, again, this formulating our algorithm, the making a plan. What's our plan of attack going to be here? So there are two techniques that I like to talk about. One of which is visualization. So this is really the idea of just kind of diagramming, drawing something. In more advanced scenarios where you have a much more complex set of logic you need to implement, you would probably use a digital medium. You'd use some kind of a tool online. You'd make yourself like a nice flow chart, right? Spend the time to actually chart these things out and make something nice and fancy, and that becomes part of your work environment. For our purposes, when we're working on these smaller, more self-contained problems, you don't necessarily need to go through the whole flow charting process, but it can actually be really helpful to visualize this just with a regular old pencil and paper. Just draw yourself a picture. The same way you might draw a flow chart in a digital medium, you can draw that just with pencil and paper much more quickly. And it's just easier to kind of wrap your head around. Just take a look at something and just sketch out boxes and arrows and moving things around. And I might take something from here and put it over there, and you just draw it out for yourself. And that's a great way to go about this. The other technique that you can use here besides that visualization technique is articulation. What that means is to talk it out. So you want to, in great detail, you want to describe exactly what it is you need to do. So I like to talk about this. I like to describe this as if, what if you needed to tell somebody else how to implement this, right? Someone else is the programmer. Maybe you're talking to the rubber duck on your desk who helps you with your debugging, but in this case, we're making an algorithm. You're talking to your rubber duck. The rubber duck is the one who needs to write this code, who needs to actually implement this, but you have to describe exactly what they have to do. So that's the articulation. That's what we're going to practice here today. So I just kind of want to walk you through an example of how this would go. And again, notice I've done a lot of work here so far, and I have a lot more work to go before writing a single thing. I certainly haven't written a single line of code, and I've not written a line of pseudocode yet either. No comments, nothing. A lot goes into this process before you start typing any characters. Okay, so let's talk about the articulation of this. So I know that I'm going to be given a number here. And what I need to do, what I believe I need to do, is I need to have a sequence of numbers that's going to start at some point. Well, it's going to start here. I know I need the natural numbers, and I was given the edge case that says if the number is negative, return 0. So let's say I'm going to start from 0, and I'm going to count a sequence of numbers up to the max up to this input number that I'm given. In our sample, it was 10, right? The example was 10. So I might think to myself, let me utilize the example data to kind of walk through this. So I know what I need to get is I need to get the sequence of numbers 0, 1, 2, 3, 4, 5 up through 9. I'm stopping at 9 because it says very explicitly here, I want to return the sum of all the multiples of 3 or 5 below the number passed in, not including that number, below that number. So again, I'm just thinking in terms of the data that's here. I want 0 through 9, that sequence. And then what I need to do is I need to examine each one of those numbers one at a time. And for each one of those numbers, I want to say, well, is it a multiple of 3 or 5? If it is, I want to do something with it. Otherwise, I can ignore it. I don't need to do anything. So if it is a multiple and I want to do something with it, what can I do with it? Well, let's see. I could store it away somewhere. I could put it in a box, and I could keep it. And all the numbers that I find that are multiples of 3 or 5, I could keep adding them into the box. And then after I'm done, I can go look in the box and add all those numbers up. That's fair. That's fine. I could do that. Something else that might occur to me is that this kind of feels like a pattern that we've come across many times before. And hopefully as we're sort of thinking this through, we might recognize that, right? It's that idea of that accumulator pattern. I should be able to maybe think through and realize, all right, I'm going to look at all these numbers. I'm picking out certain ones that meet a certain criteria. And then what I want to do is sum those numbers. I want the sum of these, right? I want to return the sum of those numbers. We've done that many times before with our accumulator pattern. It happens all over. I want to keep a running total is that phrase that I like to use a lot. So I'm thinking, okay, right. That's probably going to apply here. So as I'm picking out these numbers that meet my criteria, I can store them all and add them up later. Or wait, let me follow my accumulator pattern. I can just create my accumulator, my running total. And as I pick these numbers out that I want, I can just keep adding them in. I keep adding them to the sum. I think that makes sense. That sounds good to me. So I'm going to do that. And then when I'm done, when I've gone through all these numbers, I've examined them all, I'm finished at that point. I have my sum, I have my running total, and I just need to return it. Okay, I think that sounds relatively good to me. So let's take that idea that I just talked through, right? And there was, again, there was very little programming there. There was no syntax, right? This should be, again, language agnostic. What I'm going to do is I'm going to start writing my pseudocode. And as I do that, I might start getting some ideas. Or even beforehand, I might start getting some ideas of, as I talk to myself through that, I might have thought at the time, there are some programming constructs that are coming to mind. But I want to try, I know it's weird, I want to try to avoid that initially, right? I don't want to immediately start thinking about these programming constructs, these like syntactical things. I just want to think about the plan, the algorithm first. Then let that kind of become the pseudocode, which then becomes the code. As I walk through, as I talk through my plan, I should be able to pick out lots of different words and phrases, keywords, key phrases that will trigger in my head, this is going to become maybe a loop. This is going to become an if statement, a conditional, and these sorts of things. So let's kind of go back through our plan and see what happens. Now, finally, we're going to start typing some things. So let's go up in here. And what we said was, all right, well, the first thing I want to do is I want to create that accumulator, that running total, right? So let's put this in here. We're going to create the accumulator. That sounds good. We're going to do that. And we'll start off like this. We'll put our code in between after. Then I said, I need to come up with a sequence of numbers. Like for example, in the example data we're given where 10 is the input, right? I want those numbers 0 through 9. How can I come up with a sequence of numbers and examine each number? Well, for me, like a sequence of numbers, I might think of like some different functions that I could use, or I might start thinking of the idea that we've come across. There are some loops that'll do something like that. And especially for me, I use the word each, right? I said, I want to look at each one of these. For me, that's my keyword. If I want to do something to each one of something else, that's a loop for me. For you, it might be something else. You might have a different keyword, a different key phrase, and that's fine. Whatever it is for you that works for you, that's what you should use. But I'm thinking, I want to look at each one. That's a loop. And I know that I have the idea of a counting loop, right? The C-style loops in JavaScript. So I can utilize one of those. That's what I'm going to do. But for right now, I'm still not going to put syntax in here. I'm not writing code yet. This is still my pseudocode. So in my pseudocode here, I'm going to say, maybe I want to loop over the sequence of numbers, right? What numbers? Let me be clear. Maybe I'll just put like little like bullet points under here. I want to start at, where do I want to start? Do I want to start at 1? I want to start at 0. Maybe we'll reevaluate this. Right now, let's say we'll start at 0 and we're going to go up to number, right? With the given number that we're putting in here, the number that's coming in here. Up to number, not including number. Let's remember that, right? It doesn't hurt to give ourselves a little reminder. Not including, let's make sure we even spell it right. Number. Okay. So that's my loop, right? And again, I know I need to do something repetitively. I need to look at each thing. So I'm okay at this point with saying, I know I need some kind of a loop, the details of which I'll get to. I'll implement that in a moment. Now, inside of there, and this is typically when we write the pseudocode, we'll utilize indentation, knowing that this is probably going to turn into our scope. So I'm going to go ahead and utilize that. I'm going to come inside of here and I'm going to say, well, now that I'm in here and I'm looking at each of these numbers one at a time, I want to know if the number, let me stop here for a second. Notice that this is number, right? This variable, this parameter is called number. Here I used the word number. Here I used the word number. But is this that same number? This again is someplace that I find that beginning students can sometimes get caught up, not recognizing that when I'm looping over here, this number that I'm talking about here, that's the parameter here, this is what's being passed into me. It's that maximum, it's that ceiling. What I'm doing inside of the loop is I'm walking through the sequence of numbers up to that number, right? I'm looking at the 0, 1, 2, 3, 4, 5, not the 10. So I should probably come up with a different name for this so I don't confuse myself later when I read back through my pseudocode, right? So let's do that. This is just one of these little things that trips folks up a lot. What if we say sequence number or something like this? And I'll just even say sequence num. If the sequence num, as I'm walking through that sequence, I think that I'll recognize what that is. If the sequence num is a multiple of 3 or 5, if that is, so how do I determine if something is a multiple of 3 or 5? Well, you know what? I think I remember some things about that, but at this point, I'm going to let that be an implementation detail. I've not actually implemented anything yet. This is still my pseudocode. What I can do at this point is I can say, well, I don't know exactly how to do that, but I'll figure it out in a moment. Right now, I'm still kind of taking my algorithm, my plan, and putting it on paper. The details of exactly how each line works, we'll get there. So I'm going to leave this alone for now, even maybe not knowing exactly how to implement it. I just need to know at this point, if the sequence number is a multiple of 3 or 5? If it is, what do I do? Well, again, inside here, I'm going to know that I'm indenting. This is part of this conditional. If it is, then I want to add it to the running total. Cool. So now I'm looking through all of these numbers in the sequence. I'm checking the condition. Is it a multiple of 3 or 5? If it is, add it to the running total. Anything else at that point? Let me think through it in my head. Nope. I think we're okay. I think I'm okay. So now what I need to remember, last thing, is now outside of my loop, breaking out of the scope of my loop. Once that's complete, then I can finally say, return my accumulator. Return the accumulator. Okay. So now I've thought through my algorithm. I've got my plan. I put my plan to paper now. But again, I've separated those two processes. I did the planning first, then I wrote out my pseudocode. Right? It's too easy to skip that part, jumping straight to the pseudocode, and boy, you miss the plan. It becomes too hard to formulate quite often. Now let's go in and see if we can fill in the actual implementation here, fill in the actual code. So create the accumulator. Let's say we'll just do and we'll call this just our total. And I believe I said before, we're going to start this at 0, right? So our running total is 0 at this point. And again, this makes sense. Oftentimes it can be a little bit unclear. Where should I start my accumulator? What's the good starting point? Is it always going to be 0? Not necessarily. But in this case, if we know that we're just totaling up something, we're adding up numbers. Well, before I start adding any of them, what's my total? It's 0 at that point. So starting off 0 here is safe. Then loop over the sequence of numbers, starting at 0 and up to number, my input number. So under here, we're going to start our loop. We're going to say for, what I like to do is always set up my proper syntax first and fill in the details after. So I like to put parentheses and I put my curly braces and then I open them up, creating my structure first, and I'll fill in the details after. So now in here, I'm going to put that counting loop. And I'm going to say, let num equal to, we want to start off at 0. And we'll come back to this. We'll re-examine this maybe in a moment. And then while that num is, and this num is our sequence number again. I'm using this variable num to mean which number in the sequence in 0 through n. So I'm calling it that, and I think that's a fair name. Num is less than number. Again, not less than or equal to. Looking back here, I'm doing this up to the point multiples of 3 or 5 below the number passed in. So this is the number passed in. I want to stay below that. And then I just want to increment my counter. I'm just going in direct series. So num plus plus. Right, so we should remember this is how we set up our for loop, our counting loop. Inside of here now is, let me actually wrap this. I forgot when I talked about setting up my structure, it actually should be this way, right? These things, my pseudocode that was indented should have been inside my curly braces. So that's another thing. I almost fell into a trap that I see a lot of students fall into there. Okay. Now inside here, if the sequence number, which I'm using here as just num, is a multiple with an I, is a multiple of 3 or 5. How do I determine that? Well, maybe I remember something that we have learned in the past. Maybe I'm not sure. Maybe I've come across this before. Maybe I'm just going to go and search the internet for how do I determine if a number is a multiple of another number. I can ask my favorite search engine. I can ask my favorite chat bot. And probably what I'm going to come back with, the answer that I'm going to come back with is by using the modulo operator. So we find this in JavaScript. We've come across this in Python before. It's very, very similar usage all over. What I want to do is something like this. I'm going to say if inside of here, if that num modulo 3 equals 0. So let's start right there and we'll put in some more in a moment. Okay. Num modulo 3. This means the modulo operator. Hopefully we remember this gives us the remainder of division. If that num divided by 3, give me the remainder. If the remainder is 0, that means that, yes, it is a multiple of 3. That num is a multiple of 3. So this is how I test. What I want to know, though, is it a multiple of 3 or multiple of 5? It can be either. So let's put that in. Let's come back here and say our or, right, double bar, double pipe, or num modulo 5 is 0, right? If that's the case, let me make sure I get my curly braces correct. If the number, what this basically says, if the number is divisible by 3, if it's a multiple of 3, or that number is a multiple of 5, if that's true, then do something. Otherwise, just don't do anything. I don't even need an else here. I don't need to accommodate for that. I'm just going to skip it if it doesn't meet this criteria. So add it to the running total. Well, that's pretty straightforward. I can just go up and grab my total that I've reserved up above my accumulator, and I use my plus equals to accumulate in the number, to add it into my running total. Okay, so let me do a quick review here. I've created my running total up here, my accumulator. I've created my for loop. And again, here, there's some question as to what I want to start off with here when I'm counting through this sequence. We kind of chose 0. That's probably going to work, but let's give this just an extra moment's thought here. There's something interesting. If I know that the numbers that I'm looking for, the only numbers that I care about are the ones that are a multiple of 3 or 5. Well, I can ask myself, what's the smallest possible number that will meet either of those criteria? Because anything smaller than that, I don't care about. I'm never going to use it. It's never going to meet my criteria anyway. The smallest possible number is the number 3, right? That's the only one. That's the smallest number that is possibly going to meet one of these criteria here. So I can just start counting at 3, right? If you started it off at an earlier number, that's fine. You can start at 0, you can start at 1, but those numbers up to 3 are always just going to be thrown away anyway. So I might as well just start counting at 3. Okay. Now we come down here, we do our conditional. We check to see if we get either of those multiples. If we do, we add to our running total. Finally, we're done. We come out of this, we exit our loop, and we return our running total. So let's go ahead and run our test here. Our test looks good. We passed. We can make our attempt. And ooh, look at that. 111 passes, 0 fail. Outstanding. So again, everybody, just the primary focus here today was not so much about the difficulty of this problem, the difficulty of the logic we needed to put in here. It was more about really focusing on that central point of our problem-solving framework, which is the developing of the algorithm, making our plan. So I want you to kind of try to isolate that more. Focus on that more. Read your instructions, determine your inputs and outputs, and then before jumping straight to pseudocode, think a bit more about your planning stage, about your algorithm stage, right? Spend some more time there. Draw a picture. It's extremely helpful. Do the articulation technique where you talk it out. Describe what needs to be done to someone else. It could be your coworker over a phone call. If you just imagine that it's like an old-fashioned phone call, right? And you just need to verbalize it only. You can't show them anything. You can't see anything. That's actually like a really helpful kind of technique. I just have to talk it out. Or I just need to sit here and talk to the rubber duck on my desk, and I need to articulate. I need to talk about what exactly it is I need to do. Once I've done that and I've focused on that, then move on to your pseudocode. Your pseudocode can help to more fully flesh out the algorithm that you just kind of thought through in your head. You can always go back and refactor the algorithm. The algorithm can then help you refactor the pseudocode. That's fine. And then finally, you get to the point of writing your code. Okay, everybody. Thank you very much for your attention today. As always, if you have questions, please feel free to contact me.